Well, welcome to our lesson on solving absolute value equations. Here are your learning targets for this lesson. We're going to be able to evaluate just absolute value expressions that have absolute values in them and also solving absolute value equations. So to begin with, we need to talk a little bit about what absolute value means. And as you probably already know, the absolute value is just the distance from zero on a number line. And we can never have a negative distance, so we will always get a positive value out from an absolute value. That does not mean that we can't solve equations and get negative values. It just simply means that if you have the absolute value of something and then the right-hand side equal to a number, it's always going to give you a positive value. That's kind of confusing, but I'll demonstrate that as we go here. I have one note here for you. When evaluating expressions, the absolute value bars act as a grouping symbol. So that means that you have to do the stuff inside the absolute value bars first whenever you have those. So here's an evaluate problem, just an example of how we would evaluate if x is equal to -3. And that just means wherever there's an x, we're going to plug in the value -3. And so I've rewritten that here. Now we have to do this stuff in the absolute value first, so we get -15 minus 7, and again we have to get this down to a single number before we take the absolute value. And now whenever we take the absolute value of a number, we always get a positive value out, so that gives us 1.4 plus 22, which gives us 23.4. When we're solving absolute value equations, the definition of the absolute value tells us that either A is equal to the positive value of B or the opposite value of that. So when we solve absolute value equations, that's exactly how we're going to set it up. We're going to set up two scenarios. One where we get the stuff in the absolute value equal to the positive value on the right-hand side, and one where we get the stuff in the absolute value equal to the opposite of that on the right-hand side. So here we go. I've set up the two cases for you, and we're going to go ahead and solve these. These are pretty simple to do mathematically. You're not going to have any trouble with these. And I've lost my little, there it is, lost my x value there. So x equals 17 on the left, and then over on the right-hand side when we solve that one, we are going to get x equal to 7. Now one of the things that we have to do is we always have to check our solutions. And that will make more sense as we go here. I'm going to show you an example of that, why we have to check later. They don't always work. So on the left-hand side for case 1, if we plug in a 17, we get the absolute value of 5 equal to 5, which works. And on the right-hand side, we get the absolute value of -5 equal to -5, which also works. Okay? When we plug in a 7, the absolute value of -5, this should say +5 here. There's a typo here, so let's go ahead and change this. I'll put this in here right now. So these should say +5 over here. Sorry about that. Okay? So what that means on a number line is that wherever our center is, in this case, this tells us where we're centered on the number line, 5 units to the right or 5 units to the left give us our two endpoints, and those are our solutions. To the left we had 7 and to the right we get 17. So the number 5 is the distance from 12 on the number line. We could be 5 units to the right or 5 units to the left. Alrighty, so since the absolute value of a number is always positive or 0, an equation like this, where we have the absolute value equal to a negative value, that's never going to happen. You're never going to have a distance that is negative. And when that happens, we say there's no solution. So one of the things when you have an equation like this, you need to get the absolute value by itself before you take the absolute value. So that means we would subtract 8 from both sides. And when we do that, we get the absolute value of 3x minus 2 equals -8. Well, we can stop at this point because we're never going to get a negative value on the right of an absolute value on the left. Okay? And so we have to check our solutions. And sometimes we might not have valid solutions once we check those. Here's an example. Now everything, we have the absolute value by itself. Remember to isolate that absolute value before you set it equal to the positive and negative values. So let's go ahead and work through this. So we have x plus 6 equals 3x minus 2. Getting our like terms together and solving for x, we end up with x equals 4. On the right-hand side, we're going to set this equal to the opposite of the right-hand side. So make sure you distribute that negative all the way through your parentheses. We get negative 3x plus 2. And then solving for x by getting our like terms together, we get x equals negative 1. Well, now we need to check both of those solutions to make sure that they're valid solutions. So I'm going to go ahead and plug in 4 for the value of x, and we end up with 10 equaling 10, which is correct. On the right-hand side, we're going to replace the x value with negative 1. So we end up with the absolute value of 5, which is 5, equal to a negative 3 minus 2, which is negative 5. This is a false statement. So this x equals negative 1 is not a solution. The only solution is x equals 4. So that's an example for you of why you need to check your solutions. Here are 5 examples for you to work through as a lesson check. Just a note down here, when you get to problems 3, it looks like just problem 3, make sure you isolate the absolute value first before you move on. We'll see you in class.